In this video, we are going to solve some rational equations and inequalities. Alright, let's first start with the rational equations. An easy way to solve a rational equation is to make all of the denominators the same. So that's what I'm going to do. I can make all the denominators into x squared. So I can make this into x squared by multiplying by x, which I need to do the same thing in the numerator. I can turn this denominator into x squared by just putting an x squared down there. Alright, but I have to do the same thing in the numerator, so I've got that. Now everything is x squared. Now I'm going to carefully make sure this negative sign gets put on the 6. So I'm going to just move that up. Now once the denominators are the same, you can cancel them out and make a new equation. So my new equation is 6x plus x squared is equal to 7. I notice that I have x squared and x, so that means I want to get 0 on one side and either factor or use the quadratic formula. First of all, I'm going to rearrange this so that it's x squared plus 6x, alright, standard form. And now I'm subtracting 7 from both sides, so I'm going to wind up with minus 7 equals 0. And then I will try to factor it. X squared is x times x, 7 is 1 times 7. Inner plus outer equals middle. So inner I have 1x, outer I have 7x. If I want a 6x, I need a negative 1 and a positive 7. So negative, positive. Also, negative times a positive is a negative, so that worked. For the final answers, I will take these factors and set them equal to 0. So x minus 1 equals 0. X plus 7 equals 0. So x is equal to 1. X is equal to negative 7. Let's take note of the excluded values. X cannot equal 0 based on looking at the x or the x squared. Yeah, you can't divide by 0. Neither of these are 0, so these are both good solutions. So that's the answer to number 23, 1 and negative 7. Now let's look at number 24. Again, I'm going to make all the denominators the same. So I have 2 over d plus 2 plus 8 over d minus 2 is equal to 14 over, and I'm just going to factor this. So this is d plus 2, d minus 2. So to make the denominators the same, I see this denominator has both d plus 2 and d minus 2. So I can make this denominator the same if I multiply by d minus 2. Have to do the same thing to the numerator though. Now here I have a d minus 2, but I need a d plus 2. Alright, also the numerator. Now my denominators are the same. When I have like denominators, I can solve the equation by canceling out the denominators and making a new equation. I will do the distributive property, so 2d minus 4 plus 8d plus 16 is equal to 14. Combining like terms, so 2d, 8d, that's 10d, negative 4 and 16, that's 12, is equal to 14. Subtracting 12 from both sides gives me 10d is equal to 2. Dividing both sides by 10, d is equal to 1/5. I just reduced. Alright, excluded values. Looking at the d plus 2, that tells us that d cannot equal negative 2. Looking at the d minus 2, I know that d cannot equal positive 2. This is not excluded, so that's a fine answer. Alright, I'm going to do the same thing with number 25. I will make the denominators the same. This denominator needs x minus 1. Put it in the numerator. This denominator needs x plus 4. Put that in the numerator as well. Now the denominators are the same, I can cancel them out and make a new equation. So I am going to distribute here, so that'll be 2x squared minus 2x is equal to x squared plus 4x. I see x squared and x, so I'm going to get 0 on one side. So minus x squared on both sides and minus 4x on both sides. So that will give me x squared minus 6x is equal to 0. You got to recognize the GCF here, guys. Don't miss it. That's the first step of factoring. So there's a common factor of x. I'm going to bring that out, and that leaves x times x minus 6. To get the solutions, I set each of these factors equal to 0. So x equals 0, x minus 6 equals 0. Alright, this is a solution. Adding 6 to both sides, I get x equals 6. So what are the excluded values? Looking at the x plus 4, I know that x cannot equal negative 4. Looking at the x minus 1, x cannot equal positive 1. Neither of these are excluded, so those really are the answers. Okay, now the last few problems are irrational inequalities. As soon as I see that less than sign, I know this is going to be one of those problems where I plot some critical values on a number line and I do some test values to see where the solutions are, and then I draw them in and I do my interval notation. But how do I know what the critical values are that go on the number line? Well, there are two types of critical values which need to go on the number line. The first type of critical value will happen when we solve the related equation 6 over x plus 1 equals negative 3. And I like to solve these by making the denominators the same. So I will put x plus 1 in the denominator and the numerator. Once the denominators are the same, I can cancel them out and make a new equation, which is 6 is equal to, I'm going to distribute here, so it's negative 3x minus 3. Getting x by itself, I'm going to go ahead and add 3 to both sides. So that's 9 is equal to negative 3x. Then I would just divide by negative 3. And that gives me negative 3 is equal to x. So that is going to go on the number line. X equals negative 3. That's one of my critical values. But also, any excluded value will also be a critical value for the number line. So looking at the x plus 1 in the denominator, I know that x cannot equal negative 1. So both of these values will go on the number line. Alright, so this will be negative 3, and this will be negative 1. Excluded values are always open circles, because an open circle means, hey, this point is excluded. Solutions to the related equation will sometimes be open circles and sometimes closed circles. When I have, for example, less than or equal to, that would be a closed circle. But if I just have less than, then it would be an open circle. This is just less than, so I'm going to have another open circle. Alright, time to pick my test values. So in this interval, I'm going to use -4. Alright, and here I'm going to use -2. And over here to the right of -1, I'm going to pick 0. Alright, now at each one of these test values, I'm going to evaluate the inequality. To help me do that, I'm going to put the left side into my calculator just to make it easier for me. Alright, so here I've typed the left side of the inequality in my calculator. Make sure you're in Ask X mode. And so I'm going to start typing in the values at which I want to evaluate. So -4, -2, and 0. So -4, -2, and 0. So I got -2, -6, and 6. Now remember, in each case I'm trying to decide if the expression is less than -3. So the question is this less than -3? Is this less than -3? And is this less than -3? This is a no. -2 on a number line would be to the right of -3, so that makes it greater than instead of less than. Is -6 less than -3? Yes. -6 would be further to the left, so that is less than -3. Is +6 less than -3? Clearly not. That's a positive number and that's a negative number. So the yes shows me where my solutions are, which are right in here. So in interval notation, what I have is -3 to -1. I'm going to use parentheses instead of square brackets to indicate that the endpoints, these critical values, are not to be included in the solution set. So parentheses are used whenever you have open circles. So for number 27, again, to find the critical values, the first thing I do is I solve the related equation x over x minus 2 equals 0. An easy way to solve a rational equation is just to make the denominators the same. Once you have like denominators, you can cancel them out and make a new equation. In this case, just simply x equals 0, because 0 times anything is 0. So this is one of my critical values. It will go on the number line, x equals 0. Now in addition to that solution, another critical value will be the excluded value, x cannot equal +2. So these are the two values that go on the number line. Alright, 0 and 2. Excluded values are always graphed as open circles, whereas the solution to the related equation will sometimes be open and sometimes closed. Because this is greater than or equal to, that's when you do a closed circle. Alright, indicating that this value will be included or equal to 0. We want the values that cause the inequality to equal 0. Alright, now we will choose our test values in each of these three zones. To the left of 0, we can choose values like -1. between 0 and 2, an obvious choice would be positive 1. To the right of 2, I'm going to choose a value of 3. Now, let's evaluate the inequality at each one of these. To help myself out, I'm going to use my TI-30XS multiview. X over x minus 2. So that's x over x minus 2. Alright, make sure your calculator is in Ask X mode. So I want to evaluate at -1, +1, and 3. So -1, +1, and 3. So I get 1/3, -1, and 3. Alright, so that's 1/3, -1, and 3. Now this time we want to know whether or not these values are greater than 0. So is this greater than 0? Is this greater than 0? Is this greater than 0? Now 0 is easy because anything positive is greater than 0. Anything negative is less than 0. Alright, so these are the true statements. The yeses show us where the solutions are, and we will draw them in with arrows, and then we will reflect those arrows in interval notation. So this first arrow goes from -infinity to 0. Now we use a square bracket at the 0 to show that we're including the endpoint. Union. Now this arrow goes from 2 to infinity.
To whom should I send your message?
So that's the final answer. Okay, alright, so that was number 27. I think we have 2 more. Alright, so again, we need to find the critical values to plot on the number line. And we will get the first critical values by solving the related equation 3x minus 5 over x minus 5 equals 4. An easy way to solve a rational equation is to make the denominators the same. Alright, so I'm going to put an x minus 5 here in the numerator and the denominator. Once the denominators are the same, you can cancel them out and write a new equation. So 3x minus 5 equals 4x minus 20. I only see x's. I don't see x squared. That means I should be able to get the x's on one side and the numbers on the other side. So I'm going to subtract 3x from both sides. I could have subtracted the 4x, but I'm just going to keep it positive. You should get the same answer either way. So I have -5 is equal to x minus 20, and then I'm going to add 20 to both sides. So that's going to give me 15. Alright, so x equals 15. That's my first critical value. Now, there is another critical value because any excluded value is a critical value that should go on the number line. So x cannot equal 5. So that's a value that needs to go on the number line as well. So these are the two numbers for my number line, 15 and 5. Excluded values are always open circles every single time. Now the solutions to the equation are sometimes open and sometimes closed. Since it is just less than instead of less than or equal to, this will be an open circle. So let's pick our test values. In the first zone, I will evaluate the inequality at 4. Between 5 and 15, I'll use 10. Beyond 15, I will use 20. Alright, you don't have to use the same numbers I used. You can pick anything you want, as long as you have one value in each interval. To help me out, I'm going to enter the left part of my inequality into my TI-30XS multiview. So 3x minus 5 over x minus 5. Make sure your calculator is in Ask X mode. So I'm evaluating at 4, 10, and 20. So 4, 10, and 20. Alright, so it's negative 7, 5, and 11/3. Alright, in each case, I am comparing to the number 4. Specifically, is this less than 4? Is this less than 4? And is this less than 4? So, is negative 7 less than 4? Yes. That's a negative number. That's a positive number. Is 5 less than 4? No. It's not. Is 11/3 less than 4? Well, if I wasn't sure, I could check it. If I highlight this and hit the toggle key, I see that 11/3 is approximately 3.7, rounding up. So this is like asking, is 3.7 less than 4? Well, yes, it is. So the yeses show me where the solutions are. So I have solutions in this interval, which I will draw as an arrow, and I have solutions in this interval. There are none in between. So, interval notation. This first arrow goes from negative infinity to 5, parenthesis, because it's an open circle, not included, and then again from 15 to positive infinity. So that is the final answer. Alright, that was number 28. I think this is the last problem for this video. So one more time, we need to find the critical values to put on our number line. And we can do that first by solving the related equation 1 over x equals 1 over x plus 3. An easy way to solve a rational equation is to make the denominators the same. So I will multiply this denominator by x plus 3 to match the other, which is fine as long as I multiply the numerator by x plus 3. I will have to multiply this denominator by x in the numerator and the denominator. So now the denominators are the same. I can cancel them out and make a new equation from the numerators. So this is x plus 3 is equal to x. Now this is a little strange because I want to get these x's together, but when I subtract x from both sides, they cancel out completely. So I have 3 is equal to 0. 3 does not equal to 0. So this does not make any sense. That means this equation had no solution, but yet that does not mean the inequality itself has no solution. No solution is not the answer to the overall question. The reason why is because when we graph our critical values, the critical values come from two places: the solutions to the equation and any excluded values. Well, we didn't have any solutions to the related equation, but we do have excluded values. Looking at the x, I know that x cannot equal 0. Can't divide by 0. Looking at the x plus 3, I know that x cannot equal -3. So these are my two excluded values, so I can still draw my number line and find the solutions to the inequality. So I've got 0 and -3. Excluded values are always graphed as open circles. So both of these will definitely be open circles. Okay, time for test values. So I will evaluate at -4, -2, and +1. Now I need to be really careful what I put in my calculator when I use my calculator to help me out. For the first time, I have variables on both sides of the equation. So I can't just put one side in my calculator and then compare it to the number. So I have a choice. If I want to leave the equation in this form, then I would need to evaluate both sides. So maybe I'd have to either do this by hand and put my -4 in here and put my -4 in here, or there's something else I can do. And here's what I think is the easiest thing. Let's rewrite this equation. I'm going to take this side of the inequality and move it over to the left by subtracting it from both sides. So that's going to give me 1 over x minus 1 over x plus 3 is less than or equal to 0. Alright, that's what this becomes if I take this and I move it to the other side by subtracting it from both sides. So in this form of the inequality, now I can see that this can easily be put in my calculator. So I've got 1 over x minus, minus 1 over x plus 3. Make sure you're in Ask X mode. And we are evaluating at -4, -2, and 1. So I get 3/4, -3/2, and 3/4. Now in this form, we are comparing with 0. Is this less than 0? Is this less than 0? Is this less than 0? 0 is easy because we only need to worry about whether or not it is positive. So 3/4 less than 0? No, that's a positive number. Positive numbers are always greater than 0. This is negative, so yes, it is less than 0. This is positive, so no. This yes indicates that I have solutions in this interval. And in interval notation, this would be from -3 to 0. Now that's not an ordered pair, it's not a point, it is an interval, so we know that because of the context. We're using parentheses for the same reason that we have open circles. We're showing that the -3 and the 0 are not to be included in the solution, which makes sense because they are excluded values. So that would be the final answer for number 29. Notice that even though when I solved this equation I got no solution, we still had a solution to the overall inequality.